What's up, guys? Let's take a look at our maze problem. This is something that I created and I added to the Karel the Dog unit on our course. We start with a 3x3 tiny maze, and then we go 4, 5, 6, 7x7, each time starting in the bottom left, but everything else is a bit different. You might have to start by turning or start by moving forward. You might end over here or end over here. We have to write some code that can dynamically handle different situations. And it turns out that's not too hard. When you see the final version, you'll go, oh, no problem. But what is hard is testing it along the way, and that's what I'm going to talk about in this video. So for example, if you think we're going to go until we hit the ball, and it's a very unpredictable amount, it might be a few steps or it might be a lot, your first guess might be a while loop. You'll say, oh, okay, while, I think it's no balls present is the condition, then we do something, right? And guess what? That is logically reasonable, and that probably will be in our final version, but it's pretty terrible for a draft, because when I test it, I'm not going to have all the parts. I'm not going to know how to get to the ball, and so my while loop is going to get stuck basically every time, and the program's going to freeze, and I'm going to have to reset the page, and I won't get to see what happens. Sometimes when you have an infinite while loop on Code.hs, you got to see Karel the Dog move a little bit, but usually you don't. It just freezes instantly. So this is going to be a pretty bad testing environment, and that's what matters. When people have a while loop that's getting stuck, I often tell them to just turn it into an if, because if works the same as while, it just does it once. That would be okay, right? Like here you could see stuff happen, but it's not very good for the repetitive nature of getting through a maze, which is going to require moving more than once. So instead, what I'm going to recommend is a for loop. We can just give it a maximum. We can just say like, okay, for I in range 100. And I don't think it's going to take 100 steps, but that's just a maximum. And when I get some incomplete code that's going to circle around and never find the ball, then it'll just stop after 100, which means I'll never have an infinite loop. So what could we do here? Well, that crashes, but crashing is fine because it's easy and all we have to do is one click. What about in here? Well, we're still going to keep our condition. I'm going to say if balls present, we're done. And the way to be done is to use the word break. I don't know if that was in this unit on Code.hs, but it's a way to exit a loop, either kind of loop. And so this is the equivalent of our while. It just can't get stuck because it has a maximum. So now we're going to say, what are the other conditions? What is the actual algorithm for getting through the maze? You'll notice we haven't talked about that yet because the setup is just as important. Now we have a testable, quick, safe setup, which is pretty good. I don't know if you've ever been through a maze at Huber's or going through one of those corn mazes for a state fair, but often people say you just pick a wall, maybe you pick your right or your left, and you follow that wall. When it turns, you turn, and that means you will see every part of the maze before you end up repeating, unless there's a rare loop situation. So let's try that. Let's say I'm going to pick my right side, but if this would work for left, and if my right is blocked, meaning there is a wall, that's normal. I'm just going to keep going. But if my right is clear, that means I've gone too far and I need to turn right to keep following the wall. So let's say if right is clear, turn right. Is that going to do anything? No, but that's okay. Am I going to have any of these that start in a situation that uses that? No. So I can't test it quite yet. I need to write another piece of code that'll get me there. So let's say if front is clear, we're going to move. Okay? That seems pretty normal, right? We walked up to the wall. Is that enough to finish? No. Is that enough to test? Yes, we're getting somewhere, okay? I don't know if you noticed on that one a minute ago, it walked up to the wall and then waited just a moment and then stopped the program. That's because it was going through the for loop. It only took a couple to hit the wall, but now it's going through the other 97. And instead of having an infinite loop, it's just stopping, which is great. So, okay, what do we actually need to do? Well, apparently, sometimes we need to turn left, okay? Can I add that and be done? Maybe, because we'll have covered every possibility, right? I think what I'm going to do is to say else turn left. This is close to being the right answer. I think it's a little too much or a little unorganized, but it's darn close to being the right answer, because what are the only things we could possibly do? Move, turn, or turn, right? Maybe there's a turn around. I don't think so. Let's see what happens. Okay, that one got there, but this is an easy one. It doesn't have any dead ends. It doesn't have any weird loops. Let's try another world. This one, hey, it ended up going around. It did not try this dead end over here. It did try this one, but it got itself out. So I don't think we need a turn around, right? You could add some dedicated code for just dead ends. That's like if your front is blocked and your left is blocked and your right is blocked, then you turn around. But in this case, all we have to do is 2 lefts or 2 rights, and that adds up to what we need. So let's think about the third one. Yeah, it ended up trying a bunch of paths that were dead ends, but it got itself out, which is great. What about over here? Hey, we got that one too. I actually thought this was going to be wrong, but this might be right. This might actually get us to all the... Yeah, I thought this was going to fail, but now that we've got it, let's turn it back into that while loop that we talked about, because this thing right here is a bit silly. It was wonderful for testing, but then in our final version, we can just say while not false present, or the keyword not in Python flips a condition, true, false, false, true, and they already made 2 versions of every condition, like clear versus blocked or facing versus not. So you don't need the keyword not. You could use the no version. Either one's fine. And then let's see if it works in this. I'm testing a while loop confidently now because I've already done all of the logic of thinking about how we got there, and I'm not too worried about getting stuck. I still think we could get stuck, but it's not a huge danger. So think about this for a minute. Is this logically covering every possibility? I'm turning right first because I really want to make sure I follow that right wall around any corners. And then I might move. Do I have to put a move in here? Like, I was thinking initially about putting a move in here, but I don't have to because both of these can happen on the same trip through the loop, right? If and another if, those are separate, those are independent. They won't happen only one. But if else, those are dependent, so the else will only happen if the if didn't, and the if will only happen if the else won't. So we'll never do both of these in the same turn, but we might do both of these in the same turn. And I think that's enough to logically solve the problem. There is a chance that on this one, there is a chance that you could end up getting stuck in an infinite loop around this little standalone wall here if you're turning left or if you're turning right around it. So you'll have to keep an eye out, because I saw, and I made it in there as a little trap, that if you write your code a certain way, you could get stuck. But it turns out this is fine. If I were turning right and leaning on the right wall, that got me there. If I had turned left and leaned on the left wall, that would also do the job. Now another thing you could do is neither while nor for. You could make a function that calls itself. That's called a recursive function. So we could make a function that if it needs to go deeper, then it can just call itself again. And that's actually a very traditional way of solving mazes is called a recursive function. Did I say that already? I don't remember. But we could try that as well in class tomorrow. Thanks.